Hi, I'm Jack. It's been quite a while since my last videos, so apologies for that as I've been focusing more on my apprenticeship, but I've updated the name of the channel and I'm now ready to put a new series out. So this series is about my A-level Computer Science NEA or non-examination assessment. I was marked 68 out of 70 by my teacher, but it was moderated up to 70 out of 70 by the exam board. Now my exam board was OCR, but AQA requires the same standard software development lifecycle of analysis, design, development, testing, and evaluation. So these videos will hopefully still be relevant. But you should always read the specification for your exam board, and hopefully I can help you get a high mark too. So for my NEA, I decided to design a computer game with some basic AI based on an old abstract strategy board game. In this video, I will be looking at problem identification in the NEA. Now, there are several things you should bear in mind when it comes to identifying a problem to be solved in your NEA. Firstly, you should choose something you're actually capable of completing. Your solution doesn't have to be perfect or even fully complete, but you want to produce something that at least mostly works, and it should be achievable in the time frame you have. You'll also want a well-designed GUI, as without this it's difficult to demonstrate usability features. You'll need to use an object-oriented programming language, and to choose a project that allows for complex data structures and algorithms, and you also want detailed and well-organized documentation. Remember, especially in OCR, it doesn't matter how well your solution works, it won't score highly if you have poor documentation. So make sure to write it up as you go, because you really don't want to have to do it all at the end. Now, it's a good idea to build on what you already know. I'd made a lot of my own games previously, so I decided to build on that and just learn some simple AI to go with it. There are lots of great YouTube videos to help you learn new programming techniques and algorithms, so do take advantage of these and don't forget to include them in your bibliography. You don't have to have a completely original idea, but if you do take an existing idea, you should adapt it, improve it, or in some way make it more complex. I chose to make a game, which is a very popular choice, but there are a lot of other options. If you can relate it to a real life problem, say a hobby or a club you're part of, or somewhere you volunteer, for example, then it can make justifying your project and identifying stakeholders a lot easier. Relational database applications, along with virtual physical robotics projects using AI, are quite popular, as are simulations of things like bacterial growth rates, for example, for simulating COVID, or planetary interactions. I've also seen a very good project that used facial recognition, so there are a lot of options out there. You do need to make sure you choose a project that's complex enough to actually get high marks though. If you just make, I don't know, tic-tac-toe, then you're probably not going to score very highly. I chose a game that didn't already have any kind of online presence and used a Minimax algorithm with alpha-beta pruning to allow you to play against the computer. It worked pretty well, but wasn't perfect, which meant I had plenty to discuss in my evaluation. Minimax is another similar and popular choice for making an AI game. As an alternative, you could, for example, use some kind of procedural generation with A-star searches for pathfinding for your game, or add in networking. But don't just rely on good graphics because the marks are in the coded solution, not the artistry. You can use Unity or Unreal Engine, but make sure your code is of sufficient complexity and you don't just rely on their built-in game building features. I personally used the Pygame library to support the graphical aspects of my NEA as I wrote it all in Python. Also make sure that any project is not too reliant on SQL, as SQL doesn't qualify as a general purpose programming language. I'd also be careful about doing any kind of quiz or revision app, because while they're easy to justify, unless you're really confident you can build in required complexity, perhaps by using something like the super MIMA algorithm, it's difficult to meet that complexity requirement. I've put links to websites with ideas for projects below to help with inspiration if you need it. It goes without saying though, you should probably try and choose something you're interested in and going to actually enjoy making. It's a very big project and you'll probably do better if you're actually invested in it and enjoy the time you spend on it. Don't forget though, this project isn't actually just about making something out of code. It has to solve the problem. If you're struggling to come up with a problem, then in some times it's actually better to just decide what you want to do and then construct the problem it needs to solve. In my case, I made up that pieces have been lost from the physical version of my game, making it impossible to play. So my solution could then be to make a computer version to replace it. Your problem might be that there's no free version of what you're making that's available. You're making a more advanced or difficult version than is currently available. You might be updating an old game because it no longer appeals to today's users, or you might have just found a niche gap in the market no one else has filled. So when it came to writing my NEA, I began the problem identification part of the analysis section by briefly laying out the problem, explaining the game and the lost pieces. Talked about how difficult it was to replace this very old game that I'd enjoyed playing with my family, and mentioned some research that demonstrated the mental benefits of playing board games. I outlined the requirements for the solution, basically just a computer with enough processing power to run an AI algorithm, a suitable operating system, and that this problem lent itself to a computational solution because with the physical game unplayable, we needed a virtual simulation. I then described the solution itself at a fairly minimal level. It would have a menu with options to play against the AI or another person, and selection would then lead to a screen displaying the board in pieces. You could click on a piece to select it and then on another position to move it there. Once one of the players had completed a 5-in-a-row formation to win the game would end with a victory message and restart button. You could also include where a suitable graphical user interface will be used, identify the potential algorithms you might want to use in your solution, but I covered these in other places in more detail later. I ended this part with a detailed explanation of the physical game and its rules, including a photo of the game to make it more interesting and also easier to understand. So that's the end of the first video in the series. There is a link to my NEA in full below if you want to check it out, and in the next video I'll be looking at stakeholders.